So here we have our fourth sample question. So section 5.1, you can see it's a little heavy on the test because we have one more of these questions that have to deal with 5.1. So you can see 25% of the test has to deal from just this one section. So this guy says simplify, use the properties of exponents. It'll also mention you can also use the associative and the commutative property. So your clue of what property to use of exponents, we only know two, product rule and the quotient rule. We know that when you see a big fraction bar, that's a division symbol. So we're going to be using the quotient rule. Now the quotient rule says you're dividing like bases. Well, we don't know what our bases are yet. So let's figure out what my bases are to see if any of them match or like. So let's start by saying, this 4 can only apply to the one item directly in front of it. So we have a base of x. Okay? This 2 only can apply to the one item that's directly in front of it. So then we have a y. But notice this z, it doesn't have an exponent. Well, remember, any variable has an understood exponent of 1. By me putting this exponent of 1, now you can see we have a base, because this 1 is only applying to the z. Okay. This 13 is a coefficient. Because we're only doing the quotient rule, I'm not going to put any exponent there. When we start learning the power rule, you're going to start seeing me putting exponents for numbers as well. Because I told you, any coefficient, constant, number also has an understood exponent of 1. But because we're only going to be using the quotient rule, I'm just going to leave the coefficients alone in that respect. This 2 only can apply to the x. So then you have a mini base of x. This y, notice there's no number. So we can say, this, because we put in the exponent of 1, also is a base. So I have bases of x's, y's, I have a z, but no z down here. So we're going to try to reduce this. How? Notice that we have some like bases for x's. We're going to do it the quotient way. The quotient way is top exponent minus bottom exponent. So once I see that we have a match, x, x, keep the same like base of x and subtract the exponents. But you have to do top exponent minus bottom exponent. What else do we have like bases of? These y's. So keep y, y, keep it y. And then say 2 versus 1, subtract top minus bottom. Now the z, there's nothing to match it with. So since it was on top, just bring it over. Okay. Now what do I do with these? We're going to leave them alone and keep it as 13 over 7 for right now. Okay. So when I do this, subtract, and I get x to the second. 2 minus 1, I get y to the first. Do I need to put that 1 there? No, you don't have to. And then z, there's no subtraction. Do I need this 1? No. Now that I did my subtraction, what we can do is reduce this fraction. And when I reduce, remember how I told you you want to factor out the top and factor out the bottom and see if anything cancels out? Well, 13 is a prime number, can't break it down any further. 7 is a prime number, can't break that down any further. So we can leave the coefficient as 13 sevenths. This is one answer that you can have it as. Now some people will write the answer like this, one big fraction bar. And then they'll ask yourself this. Remember the 2 questions I say to ask? Where do you have, instead of saying top exponent minus bottom exponent, for the x's, where do you have more x's? Top or bottom? 4 versus 2 I have an extra on top. So I'll put the letter X on top. By how many more? 4 versus 2. Looks like there'll be an extra 2 on top for X's. Now, Y's. Notice I have 2 on top, but 1 on the bottom. Where do I have more Y's? On top. So notice I put the Y on top. The reason why I'm pointing this out is because I told you, we're going to have sometimes more Y's at the bottom when we get to section further along. And then Z, 1 on top, no Z's at the bottom, so there's more Z's on top by just 1. Notice if they're 1s, I don't write them in. 13 is left on top. 7, though, is left at the bottom. Can I break down 13? Can I break down 7? No. So this can also be your answer. Okay, so if you look at some of the answers, you go like, why does it look like this and not this? Or why does it look like this but not this? They're equivalent, and the reason why they happen is because this is using the definition of the quotient rule. This is using the question of where do you have more of like bases, top or bottom, by how much more? We're going to be using this method more often when we're going to be talking about negative exponents.